range. There's a range in that.
All right,
So I don't know.
here we go. Welcome to the February 2026 HAL meeting. This is our agenda for this evening. We're going to kick off with welcome introductions, book of the month, auction update. Got guys online. If you're
The doctor? Yes, he needs acceptance. Should I be the doctor? Yes.
can you please put yourselves on mute?
Quick question. I have some PP in my body. I'm gonna go to the body. You have any PP in your body? No?
They got the message. All right. We have the auction ongoing. We'll do a quick update on that. And we didn't really have an official speaker for this month, so we kind of cobbled together some interesting stuff. We do have a nice presentation coming up from Arjun. I know most of you know Arjun, so I'm looking forward to that. So we'll start off with the introductions. Is there anybody here in the room that is new that would like to introduce themselves?
Definitely be me. Hi, I'm Jay Sandusky. Joined last night.
Oh,
Been thinking about participating with you all for a long time. Moved here about 8 years ago and finally started to do it. So I'm happy to be here and just be a part of what's going on.
that's great. Welcome, Jay. Nice to have you with us here. Anybody online want to say hello?
Hey, Jim, this is Ken Saul. I don't know if everybody else has this problem, but all I can see is the audience. I can't see the slides.
You can't. Okay, thank you, Ken, for saying that. Let's see.
Okay.
So I guess there should be a share, correct? Here it is. Share. To share my screen.
That's it.
Yeah,
there we go. There we go.
Awesome. Ken, thanks for pointing that out.
Sure.
So any new folks online that want to come off mute and say hi?
Yeah, how you guys doing? My name's Al over here in Severn. Long time listener, first time caller.
Welcome. And do you have a telescope or?
No, I do. I'm playing around with some deep sky camera work, and I came across you guys on Facebook, and I was like looking at some stuff you guys are doing. So, been playing up with some stuff since I was a kid, but now that I'm old and getting hopefully retired one day, I'll be able to play a little bit more. But I'm always interested in deep space stuff and what's going on in the area with this.
Well, we've got a sweet imaging setup for you on auction this evening. So if you have a few grand, you can get started right away.
I'll ask my wife.
Yeah, I said I wanted to buy some stuff, but it would be too expensive because the divorce would just be too much. So
Yeah, cheaper keeper. All right.
So I'm going to give a little bit about myself here, since I'm not really new. I mean, I've been here with HAL in 2014, and in fact,
I'm going home. Bye-bye.
Can you please put yourselves on mute? I was around at the beginning too for a while. I've been a VP for the last 4 years. I was infrequently attending prior to the Zoom hybrid meetings because basically the distance. I live in Towson, and so for this evening, it was I left about 5:30. By the time I made a pit stop for fast food and got here, I got here at about 10 of 7. So Beltway traffic is just horrendous. So as a result, I may not know a lot of your faces and names. I know you. So I'm going to ask for your indulgence, please, while I gradually piece together the names with the faces. That is not my forte, so that will be me. I will be a little embarrassed more than once when I have to say, and your name is again. So please, bear with me.
You'll be the first president to get the names. I started from.
Yeah. Former dentist and then converted to be a software developer. We can have a beer one night and talk about that one. I am big, those of you who do know me, into planetary imaging, love doing planetary imaging stuff. I am the webmaster for the ALPO, the Association of Lunar and Planetary Observers. I'm the webmaster, stood up their website. I do your shallow sky slides here. And you will notice, those of you who know me, I really cannot sustain my voice for long periods of time. So we'll have people jump in and do parts of the program here. I did bring a speaker that I may try using so that I don't have to project quite as much, but we'll see how that goes. All right. So, David, are you on for the book of the month? Is our librarian online? I'm not sure. I don't think so. Okay. So we have a book of the month, American Moonshot, JFK and the Great Space Race. How appropriate for the fact that we're going to be heading back to the moon, hopefully this year sometime. Author is Douglas Brinkley. Book is 548 pages. The librarian marked it as beginner friendly. And other than that, I can't tell you much about it because I've not read it. However, this certainly seems like it'd be a great book to delve into, to get some history and context about how we got to the moon in the first place. And just a plug for the HAL library, it's got an amazing depth in terms of books that you can check out. I don't necessarily know that this one is in the library, it may be, but from books like this to actually observing guides and whatnot, the HAL library is a great resource. It's one of your benefits as a member. All right, I'm going to turn it over. I'm going to go get him and make him come do this. I'll be right back. You want to talk about the auction?
No, come on.
Hang on, guys. Our observatory director is going to come talk about the auction here in a minute. That QR code will take you right to the auction site so that you can bid to your heart's content.
Hello, Victor here. As observatory director, I guess Jim wanted me. I was just handing off the Sea Stars to a new member, giving them a quick rundown on how to use it. So I didn't really prepare. These are Jim's slides, but I'll just go forward. So we are in the process of having a live auction right now. You go to this website and you can do it at home and open another window. If you're here on your phone, you can do it. And so just like any auction, you can try to outbid somebody at the last minute, but it's not a blind auction. You can see what other people have bid on. So you can, depending on, who wins the auction or whatever, you can, coordinate with me to I can get you the stuff. All of this gear is donated by a member last year. And it's some actually very nice, it's a very high quality astro photography rig. So anyways, it's all on that website. I wonder if we want to just open up a browser. But it's some really nice gear, and all the proceeds will go to HAL, like to fund our upgrades to our observatory and our outreach efforts. So I think that's it, unless
But one thing I want to interject based on the last auction we had, this point about last minute, and people on eBay, hey, I'm going to sneak in there at 8:44 and I'm going to be the final bid and I'm going to outbid that guy. That's risky because we are not responsible for the platform. If for whatever reason it times out or whatnot, it is what it is. So if you want something, I would suggest over the next hour or so, go ahead and bid on it. make sure that you get your winning bid in. Also, for those of you here in the room, we've got QR codes that will take you directly to the various items here. So, feel free to get up and scan the QR code and put your bid in if you're interested. All right, Jose, I don't think Jose's.
I don't think he made it, no.
He didn't make it. All right.
Jose was gonna bring some of the stuff to the meeting. So it's still at Halo, and if you win it, again, just send me an email and record me. Handoff.
All right, so in terms of the star parties, Jose is our new events coordinator. I know that we've had a couple of impromptus. Wayne, do you want to say something? Because I think you were at least one of them.
Yeah, I posted an impromptu on January 20th, which I believe may have been the coldest in HAL's history. I have a recording thermometer device that I had on my telescope, and it recorded down to 5 degrees.
Was that coldest in Hell's history or Hal's
Hal's
history?
history.
Hal's history.
Or possibly the other two.
It's cold as hell.
But it was a very successful star party. I'm glad everybody that came out, and we mostly had a good time.
Later on, we'll see a picture that you took that evening. It's really great. So
Tomorrow's gonna be warm, so their mouths will thaw out. They could go get them out of the parking lot.
and we do have the Star Party season will begin anew for 2026. March 14th is our members only Star Party. March 28th is the public one. And then in April, the 18th and the 25th. So gear up. Hopefully the weather will be better by the time the spring rolls around. No promises.
Jim, just interject right here. I'm seeing some notes in the chat. Some people are saying that their next slide and notes is showing up, the speaker's presentation, and somebody said they were waiting to get in the waiting room.
Okay, I'm not familiar with the waiting room. I didn't think we had that as a. Should be there's no waiting room that I'm aware of, Joel.
Okay, Arjun, and if you're online, you're the one that posted that for your sister. Can she not get in?
Yeah, it says waiting. Maybe I think the iPad just is super slow right now.
Okay.
Yeah, log off perhaps and try again.
Yeah.
And Jim, I'll keep an eye on your chat.
Thank you, Joel. Is this better? Or are you now seeing the actual slide? Somebody give me feedback at home on Zoom, or you see?
No, it's still the presenter view.
All
Yeah,
right.
same thing here.
So you can go to, when you go to share screen, say,
Is it this one here?
no, it's screen 2, this one.
All right. Audio visual guy says this has probably got it. Is it good?
Yay, you got it.
Yeah, sure is.
All right. Yes, the recording was started.
It is recording. It's the little.
So Aldous, are you online? Can you come off and give us a little overview about the Astronomical League?
Sure. Can you hear me?
Echo.
Yeah, a little bit of an echo there. Do you have like 2 devices on at your house?
Maybe.
Oh, jeez.
Let me.
You have to go into the audio and check which one you want.
Hey, Jim, this is Dave. That's hard to interrupt or jump in. I couldn't find the link right away, so I just got in a few minutes ago.
Okay. We already covered the the library book. Do you want to say a
Oh.
few words of that while Aldous is
Can you
seeing
hear
about?
me?
Can you hear me?
Yeah, I can hear you.
Okay, yes, I heard you, Dave. Let me see if we can back up to the book here.
Sorry about that. Like I said, I lost the link and couldn't find it. So
There you go.
yeah, so picked this up several years ago. I'm not sure how many of you guys are familiar with Douglas Brinkley. He's a really good historian, but does a really good job of uh, covering a lot of the behind the scenes and the backstory of the space race and Kennedy's involvement with it. Uh, it actually came out in time for the 50th anniversary of the Apollo 11 moon landing. So, like any kind of historian's book, it's lengthy, but it definitely keeps your interest. I found it really worthwhile. So, especially with Artemis moving along, I think it's something that's good to just see a little historical perspective there.
All right. And you say it's a beginner-friendly book?
Definitely.
All right. Very good. Thanks, Dave.
Okay.
Let's click through these. All right. So Aldous, you want to try once more? See if we can get you?
Can you hear me?
Yes, and no echo.
Okay. All right. Uh, so, yeah, thanks, Jim, for asking me to talk about the Astronomical League. What is it? It's a nonprofit federation of nearly 300 astronomy clubs and individual members, and it their motto is to share the power of awe. And a little bit more info on AL, not to be confused with HAL, is that the Astronomical League is divided into 11 regions that covers the whole USA. And they even have an international region that covers Antarctica somehow. I'm not sure. But and our club is within it's called the Merrill region, which is the Mid-East region. And it includes the states of Maryland and Virginia, West Virginia, PA, and Delaware. And the reason I'm talking about them is because the board, our board, elected me to be what's called an AL Corps, not to be confused with Al Gall. There's a lot of abbreviations here, but Al Corps is the Astronomical League coordinator. So my job is to pass on information from the Astronomical League to you and to give feedback back to the Astronomical League. And if you want to get in touch, you can email me. My email is on our HAL website. It's under the new officers, and I'm the Alcor. So my name's Aldous, and I'm your Alcor. And how do you join the Astronomical League? Well, you don't have to worry about it because your dues have already been paid for by HAL, our club. And so you don't have to go to their website and become an at-large member and to share in their benefits. So we can get to the fun stuff now. If you show the next slide. So this is what's really cool. All of you should have received Reflector magazine. It's a quarterly magazine published by the Astronomical League. Can you see my video? Probably not. But there's a picture of one there on the slide. And
Yeah, we see it.
if you don't get one, I guess you can talk to or email me, but I think it's whoever's in charge of the website membership. When you paid your dues, maybe you didn't check that you wanted to receive it, but everybody should be getting one on a quarterly basis. And next bullet point, I guess. So I encourage everyone to go to the Astronomical League website. You can find it just in your browser, and because of the really cool resources they have there, there's this nice navigating the night sky. Let's see. I don't know. Do you see my video or not? I guess you stop. Do you see me or not?
No.
Oh, you don't see me? Okay, I think something went wrong with my volume, and well, at least my volume's working on my video. But there are nice graphics that they have. For February, you were emailed them in the HAL Google group, and I'll be forwarding the ones coming up in March, and they're sky charts that are really well done in color and very simple to use, along with when certain objects are up in the air. That's that timely observing activities. There's outreach downloads for those of you that are educating kids. There's great resources there for outreach. And it's all PDFs, and even like a book, that last bullet item, taking your first steps in astronomy if you're a new member or just getting started. And all this stuff is in one spot. That's what I was very impressed with going to this Astronomical League website. So if you want to know where a star party is in driving distance, you don't have to use an AI tool. Just go to the HAL website, and all that information is there from all the members in a and there's observing briefs, topical flyers, taking your first steps, as I mentioned. I've used the ABCs of stargazers for stargazing. They're great, like printouts for kids, because they also support this library telescope program that we can talk about at another meeting. But they give out AL gives out telescopes to their different clubs to take to libraries, so people can check out telescopes for free like they do books. Next slide. And some more benefits, really cool observing programs. They have, I don't know how many, probably 60 award coordinators for different observing programs. I see on the right there on the slide, I guess these are members from our club that have participated in the different observing programs. And so the way you go about it is you go to the OWL website and you go to the observing program webpage, and you can see you can earn pins or certificates for observing everything from not just deep sky objects, but just with binoculars or just with your naked eye astronomy, all levels for kids. There's a sketching. I know some people in our club are into sketching. There's a sketching award, actually monetary award if you have sketches that win. And what's next? Let's see. Next bullet item. If anybody here is there someone in the room that's listed there that's participated in an observing program? Would they like to talk about it a little bit?
Ernie. So I'm Ernie Wright, and I do moon visualization for NASA, and so I thought it would be appropriate for me to get the moon observing certificate. It's I learned things as I was working my way through the list of observations that you need to make. And I really enjoyed having that structure for the winter observing that I was doing. And now my certificate is on the wall in my office. Right.
Yeah, thanks, Ernie.
I
Yeah,
had a similar experience. I did the Jupiter one, and I thought, oh, this will be a piece of cake. I know Jupiter. I've been observing it for years. Learn stuff, and I think that's really a hallmark of these programs. They're very well put together. You can definitely learn something, even if you think you know it all. Go ahead, Aldous.
and then you get your name published in the Reflector magazine. You can put that on your wall too. Um, and there are more awards, for club webmaster. I'm not sure exactly how to go about nominating our website, but these are things we can explore together. Next bullet item, I think there is one. And I mentioned this, the Youth Astronomy Awards. There are all kinds, you don't need a $10,000 setup. You can do stuff with a naked eye, observing or sketching, as I mentioned. And there's Horkheimer. If anybody watched those PBS TV shows, they have a Horkheimer charitable fund that provides awards for kids and imaging and communications awards. And I guess they go do show and tell at their schools, and they just want to recognize the young astronomers too, not just all of us retired folk. And I think that's it for me. I just wanted to mention it also that they have a national convention that's written up in the Reflector magazine. It's going to be in Cincinnati, which is kind of driving distance. It's in August. So I encourage you to go to their website and check it out. There's just a ton of resources there.
Very good. Aldous, thank you. Appreciate that. Hopefully, like you said, we can have some additional little vignettes in future meetings about the AL and some of its benefits and programs.
Jim, I
Thank
might
you.
add from here that about 5-6 years ago, HAL was the Mid-Atlantic regional winner of the Library Telescope that year. And so our telescope is out at the Glenwood Library. And I know also Miller Library and East Columbia Library also have lending programs in Howard County.
Very good. Excellent.
Thank you.
Thank you. All right, so another little part of the program here this evening, I want to talk about HAL benefits. I think sometimes we don't really, especially for new members, to let you know some of the benefits of being a member. Tonight, I wanted to talk about the C-Star Loaner Program, which we started a couple of years ago. Those of you that don't know, C-Star is basically a hands-on telescope that is an AI sort of deal. It's compact, not very big at all, and you control it via an app on either your tablet or your phone. It makes astrophotography incredibly easy. And instead of manually aligning, focusing, and processing the images, the C-Star handles just about everything automatically. The biggest thing you have to do is decide what it is that you want to photograph for the evening. So as I said, to operate it entirely from your phone or your tablet, it finds and tracks the object for you. It shows the stacking as it's going on. It lets you save the photos directly to your device. It'll even let you save the sub.
There we go. Hey, well, the artist mission was successful. He said we're all right,
so
the eagle is. Oh, what, that was 50 something sticks here.
So trying to get back to the display. There we are. We were talking about the C-Star before we were so rudely interrupted, but the bottom line is very automated scope, great for taking astrophotography, astrophotos, can even take lunar and planetary ones. We had a great presentation at a HAL meeting a couple years ago. And there's the link to it where Grace talked about the sea star and ran through. It was a pretty kind of new item back then, but I don't think anything's really changed. That's a great meeting that you could look up on YouTube to learn more about the sea star itself.
And Jim, I just handed the Sea Star off to a young new member who's very excited about using it.
And that's great.
And they will bring it back to the next club meeting. So if you sign up, there's a sign up sheet. If you go to the HAL website, there's a link to a sheet you can sign up and get in the queue for having it.
Hello?
Oh,
Hello?
sorry.
Yes. Can you hear us?
Hello?
That's on there.
Yes, we can hear you.
Oh, okay. Can you see the screen?
Yep, you're good.
Yes.
Okay. So basically, like Victor was just saying, somebody signed up for the Sea Star. It's open to adult members of HAL, 18 years and older. You can find all the information, as you can find a lot of information on the HAL website under the Sea Star Loaner Program. By the way, the slide deck here gets posted after the meeting, so you can reference this. You basically will use a Google sign-up sheet. You review your obligations as the person checking it out, complete the form with your contact information. Requests are generally processed chronologically, and usually you'll pick it up at a HAL monthly meeting and return it at the following meeting. You can at times make other arrangements with the observatory director to drop it off. And we will obviously reach out to you when it is your turn for the Sea Star. Okay, so now we come to the part in our program where Arjun is going to give us a little bit of a discussion about a program he participated in. Arjun is a sophomore at Marriott's Ridge High School, and he's been active. He's a fixture around HAL. He's been a member since 2021, although he's been here much before then. Been doing star parties since 2016. He's really a cornerstone of our outreach efforts, running the solar system table. Always has great enthusiasm and clear explanations, and without a doubt, he's inspired a lot of visitors who have come out to our star parties. Actually, this is not his first rodeo. In 2022, he delivered a presentation at our February meeting entitled Quantum Tunneling and Nuclear Fusion. His curiosity is always evident, whether it be something like this or the questions he asks of a speaker. And he has a focus on the future of asteroid mining. In addition to astronomy, his hobbies include classical guitar and visual art, including joining the International Association of Astronomical Artists as a student member. So Arjun, I'm going to try to let you take over here with a share.
Yeah.
Let me see if I can get out there.
Move to the right of your screen.
That's what I was, there we go. All right, I think if you request, I'll get the request on.
Yeah.
Yes. There you go, it's on the screen, it's on your screen.
Okay, is my screen being presented now?
It's probably.
Yep.
Hang on,
Okay.
not here in the room. Hang on.
We see it at home.
Okay.
Find something.
They said it wasn't in the room yet.
Not
So
yet.
There we go. Just expand it over. Pull it over to the, just blow it up. Yeah. You could just drag it over. Oh, I see. Yeah. There you go. Yeah.
Okay, Arjun, you have the room.
Okay. So, hello everyone. First, I want to thank Dr. Tomney for giving such a great introduction about me. And that pretty much said everything I wanted to say in my introduction. But today I want to talk about the Pulsar Search Collaboratory and my visit to the Green Bank Observatory. So first, okay. So this was my introduction, but Dr. Tomney covered it fully, so I'll just go on to the next slide. Oh, and the visual art that Dr. Tomney talked about, these are some of my paintings on the side here. And then all the way up in the corner, that was when I was first getting into astronomy. This was when I built a telescope. And so on, yeah. So after this, now I'm going to be talking about the Pulsar Search Collaboratory. So what is the Pulsar Search Collaboratory, or PSC? So it is an alliance between West Virginia University and Green Bank Observatory founded by the NSF. And it's basically a citizen science research program for high school students, teachers, and undergraduate students. So I was a high schooler last year and I was able to participate in this program. So this program uses real radio astronomy data from the Green Bank Telescope and the Arecibo Observatory, but now that it's gone, it's just the Green Bank Telescope. So the Pulsar Search Collaboratory allows students to use data from the Green Bank Telescope and observe and find new pulsars. So students analyze plots. And on the down right hand corner, you can see this is me. And then in the back, you can see the 100-meter Green Bank Telescope. And this was out in West Virginia. So the campus was super mountainy and full of nature. So I liked the trip. But behind me is the Green Bank Telescope here. So now that you know what the Pulsar Search Collaboratory is, next let me go over what a pulsar is. So a pulsar is a rotating neutron star, which forms after a supernova. And so, in case you don't know what a neutron star is, that's basically a star which is composed fully of neutrons. It's super dense, and I think I'll be going over a little bit more on the next slide. So one of the key features of pulsars is that it has a strong magnetic field and it has beamed emission from its magnetic poles. So it emits all kinds of electromagnetic radiation and it's a super powerful object. And so as the beam of emission sweeps over the Earth and a radio telescope captures it, there's a little pulse. And that pulse keeps repeating because because the pulsars are rotating. And so whenever the pulsar is rotating and then the beam keeps going over the radio telescope, it pulses, and that's why it's known as a pulsar. Because it pulses when the beam crosses the Earth. So, the formation and properties of pulsars next. So, pulsars form when a core collapse supernova of a star, which is greater than 8 solar masses, happens. And so, after this supernova happens, all that's left is the super dense core of the star. And so they're usually 1.4 solar masses in weight, but they're only 10 kilometer in radius. And it's so many neutrons packed within such a tight and dense space. This causes huge amounts of energy, which causes the magnetic fields and the beam emissions to form. So these pulsars, like I mentioned, the main fact about them is that they're rotating. And the spin periods of the pulsar are usually between seconds to milliseconds. And these millisecond pulsars, as they're called, are some of the fastest moving objects that we know. So here's a little diagram of the pulsar. So you can see there's the neutron star in the center, and then the beams of radiation going outward in either direction. And looks like this one is rotating sideways. So after this, the next step is how are pulsars detected by these radio telescopes? So like I was mentioning before, these pulsars are rotating super fast and have highly periodic signals. And their periods are so accurate that they even rival atomic clocks. And this periodicity survives for long durations of time. So because of that, these pulsars are super easy to detect because they are emit strongly in radio. And so seeing a pulsing radio signal is a prerequisite to being a pulsar. And so you can see on the top right corner, that's a graph of a pulsar plot. So this is just a single pulse of the pulsar. And so it'll be quiet, but then as soon as the pulsar sweeps over the detector, you can see that pulse there. Oh. And usually for pulsar detection, you'd want to do two plots because one plot could be anything else. So, detecting pulsars with radio telescopes. So radio telescopes are just like normal optical telescopes, except they have much larger collecting areas and they observe radio waves. So these radio telescopes have large collecting areas, super sensitive receivers, and so because of that, they're the ideal tool for detecting pulsars. And so whenever a radio telescope is looking for pulsars, they look for periodicity. So is the pulse periodic because the period is really accurate. And then they look at the dispersion, which tells them how far away the pulsar is or the source of the radio waves are. And this can help them determine whether it's a pulsar or maybe some kind of other noise or radio frequency interference. And then finally, they look at the signal to noise peaks, which can tell you how strong the signal is. And that'll be a good determinant for whether it's a pulsar or not. And so on the top right-hand corner, I have an example of what a sample data set from the Green Bank would look like. So this is a candidate confirmed pulsar. So this pulsar data has been reviewed and confirmed to be true. And you can see here on the pulse plot, there are two distinct pulses, which are the pulses of the pulsar. And then in the DM, there's a sort of sine wave shape, which shows the electron, sorry, which shows the beam of the pulsar going towards the Earth and getting the DM less and then going away. And so you can see that as a single pulse. So this is how we detect the pulsars. And next up is the training and certification step. So in order to be an active member and data analyzer and data collector with the PSC, you need to go through training and certification. And so this basically involves a 6-week online course where you'll learn everything about pulsar physics, data interpretation, and radio frequency identification. So pulsar physics is the science of pulsars, how they're formed, how they rotate. Data interpretation is taking the data from the Green Bank telescope and seeing whether it's RFI, which is RFI identification, or if it's noise, or if it's a real pulsar. And so with the training and certification, there's also weekly meetings with the hosts of the Pulsar Search Collaboratory, and they get to answer any questions that you have with the research there. And this certification is required to grade the pulsar data and is also required to take observations using the Green Bank telescope. And so on the side here, you can see um, more examples. This one is the same one, and then this one, it's a different kind of plot, but it still shows the direct measure, the signal to noise, and then the phase. So analyzing plots. So when you look at a plot like this, you're going to be looking for the signal to noise plots first, because that's going to tell you where the pulsar is from or how far it is. And so you'd have a graph like this, and so you'd have to tell from this this graph is definitely not a pulsar because of the direct measure and the signal to noise. But with a clearer plot, you'd see a clear sine wave graph of the DM, and then you can see a clear step feature in the signal to noise. And so we look at the period signal to noise plots, we look at the folded pulse profiles and the frequency behavior. And so with that, we need to decide whether it's a pulsar, a known pulsar, or just noise. And so some of the interferences that the Green Bank telescope can receive, because it is an extremely sensitive instrument, is it can pick up satellite signals, it can pick up Wi-Fi signals and electronic signals from nearby, and it can also pick up aircraft. And many of these signals look pulsar-like because they are bright in the radio and repeating. But by checking the direct measure, you can see how far the source was, and that can help you discern whether it's a pulsar or just a man-made source. So how do candidates turn into discovery? So once you're done observing every single green bank plot, so if you receive a plot, you first look at all of the different plots, and then you'd mark whether it looks like a pulsar plot or it doesn't look like a pulsar candidate. And so once you do that, you'd flag any strong candidates by marking it as a potential new pulsar. Then you cross-check with known pulsars about whether it is a already known pulsar, if it could be a new candidate pulsar. And then after that, you'd want to reconfirm whether it's a pulsar or not, and then send in the request to re-observe the dataset and then see if it is actually a pulsar. And in case it is a real pulsar, this would be published in scientific papers, and you get to name it. And so now I'm just going to go over a quick demo of what it looks like in the Pulsar Search Collaboratory. And so this is the Pulsar Search Database website. And here you receive all the data. And so these surveys under my surveys, these are different telescopes observing different pulsars. And so all of these are just sending out signals to the students of things that the computer thinks is a pulsar. So if you take a look at one of these surveys, I'm going to find one which has data. Um, it looks like this one. Okay. So this one has data. And so this survey, which is just put out new data, the data have their IDs. So you just go in and then you need to look at the plots. So it looks like this one doesn't have the data available on it yet. So I just need to find one which has data. Data not available either. Okay. So some of these plots are empty because the telescope hasn't observed yet, but I should be able to find a plot which has data. Um, okay, looks like this survey doesn't have data. And this is one of the things. Some of the surveys might not have any data at the moment, so I'll go and check another one. Looks like this doesn't have it either. Okay, looks like none of the telescopes have data available right now. But if there was a data set, if I could find a data set, what it look like is okay. So here's a data set which has data. So this is what it would look like. So here's a signal to noise ratio, And so we would first analyze this, and then next we would analyze the DM and whether it seems to have the curved shape, which would tell us where the source is coming from. So this one seems to have a sort of blocky shape, which could tell that it's just flying at a stable altitude, so it could be some sort of aircraft. And then this is also showing that here, no significant peaks. So I click grade, and then depending on what each of the plots are telling me, I decide whether it is or not. So this one looks like the DM doesn't really look good. It looks like an object which is flying somewhere above the Earth's atmosphere. So I'd say that this is probably just RFI from some kind of aircraft.
Hey, Arjun, can I ask
Or
a
maybe,
question?
yeah.
Did you say earlier that the signal to noise ratio will provide you information on the distance away the pulsar is? Or did I mishear that?
Oh, I think I might have said distance, but I meant to say the strength of the signal.
Got it back.
Thank you.
Okay. I'm not sure, but I meant to say the strength of it'll determine the strength of the signal, not the distance. The dispersion measure is what tells you the distance of the pulsar. So, a lot of these plots might not have data, or they might have bad data, which of just radio frequency interferences. And so, after looking through and picking through all of these plots, you finally have to find a new candidate pulsar. And so, that's how candidates turn into discoveries by looking at all of these data sets. So, I'll and um, go back here and then show a pulsar plot which I found that was a new candidate pulsar. So these were some of the pulsars that I marked as new candidates, and then one of these was checked. Okay, this is the one. So I was grading data one day and then I came upon this plot. And so this is a perfect example of a pulsar plot. It has the two peaks, which shows that it has the pulsar peaks, and then the DM also shows a clear wave, and that can show the beam sweeping over the Earth. And so I was able to confirm this with some of the people over at the Pulsar Search Collaboratory, and they confirmed that this is a possible new candidate pulsar. So it's been sent out for re-observation to determine whether it's a new pulsar or not. So that's how candidates turn into discovery. So finally, I'll be talking about my experience going to the Green Bank Observatory. And so this is just a photo of me behind the visitor center. And then out back behind the visitor center, that's where all the telescopes are. So first, a quick intro to the Green Bank Observatory. It is a radio observatory located in Green Bank, West Virginia, within the National Radio Quiet Zone. It's an area protected from human radio interference, and it's a large area. I'm not sure exactly what it is, but I think it might be, it's either 1,200 or 12,000 square miles. But it's really out in the deep woods, so you can't tell. So this Green Bank campus hosts 7 major radio telescopes, which range from 12 meters to 100 meters in diameter, and it also hosts many historic and educational instruments. And so this right here is a above the sky view of the campus. The telescopes are lined back here, and then one here, and then this is the main Green Bank telescope, the 100 meter. And so these telescopes support cutting-edge astronomical research, spacecraft tracking, atmospheric studies, and educational programs like the PSC. And so the photo at the bottom below shows a telescope which was built in someone's mom's backyard. So I found that kind of funny. And I think if you see here, it's called Backyard Inspiration. That's the name over there. So now here's an overview of all of the telescopes there. So the first telescope is the Robert C. Byrd Green Bank Telescope. This is the 100-meter Green Bank telescope. It is the world's largest fully steerable single-dish radio telescope, and it is also one of the world's largest moving objects on land. I think some instruments in Russia beat this, but this is still one of the largest moving objects on land. So this observatory operates from 0.1 gigahertz to over 100 gigahertz, which is a wide range of radio frequencies, which allows the telescope to do lots of research from pulsars to molecular clouds. And the Green Bank telescope, the 100 meter, is used by astronomers globally for research and education. Some of the historic telescopes over there are the 43-meter telescope, which is a historic research instrument which was used for astrochemistry and satellite tracking. There's the Green Bank interferometer, which is three 26-meter dishes, and this is a part of a interferometer array. And then there are the 13.7 and 20-meter Green Bank telescopes, which are used for educational projects and geodetic projects. And the 20-meter is now a part of the educational network of Skynet. And so that's where students get to use these robotic telescopes. And the 20-meter is part of the Skynet network. And so this photo up here, that is the 20-meter Green Bank telescope. And then behind that, the photo in the bottom are the 26-meter and 42-meter. And the telescopes gets larger as you go down the paths. So some of the educational and outreach telescopes that are there. First, there's the 40-foot telescope, which was built in the early 1960s. It is one of the first automated telescopes. And now it's used for student projects and outreach. And in fact, when I was at the Green Bank telescope, I was able to manually operate the 40-foot telescope. The 40-foot telescope doesn't have automatic tracking because it doesn't have a motor in it. So I had to manually turn a wheel in order to get the telescope to track. And we were observing the center of the Milky Way. And so the next telescope is the 20-meter telescope, which is remotely operable and used in educational collaborations. And there are two different 20 meters. The first one is used for Skynet, and then the second one is used for other educational collaborations. And then these telescopes support the programs where students and the public can remotely observe any radio target and learn real observational techniques. And these are some of the telescopes that are supplying data for the PSC. So at the Green Bank summer camp, I was able to do my research apart from pulsars, and that was fast radio burst research. So my project at the Green Bank summer camp was the repeater fast radio burst follow-up project. And so this is a search for repeating fast radio bursts. And so for a little bit of context, a fast radio burst is a mysterious radio signal which happens um, all over the universe. It is a sudden fast radio burst, and the causes haven't been determined yet. And that's why it's called just a fast radio burst. And some of these radio bursts repeat, and that's what we call repeating fast radio bursts. And that's what my research at the Green Bank was focused on. So we focused on the target fast radio burst 220718A. That doesn't really mean much, but that's just the pulse. That's just the fast radio burst name that we observed. And so we did research on it, and our research was using this to identify new repeater candidates for the PSC database, and also observing the wavelength differences in reaching the Earth. And so we were able to combine already archived data with new observations to do our research. So about repeating fast radio bursts. So all about long period fast radio bursts. So not all fast radio bursts repeat, but the repeating ones are usually non-periodic, which means that it doesn't happen at a predicted time every single time it repeats. So I would have to So the team would have to find a set window where the fast radio burst could repeat, and that's how we were able to get our observations in. And so because of its non-periodic nature, it makes predicting future bursts challenging. Um, but that was a struggle which we had to overcome by keeping the telescope pointed at the target for multiple days. So the main research that we did, apart from looking for new candidate FRBs, were show multi-component bursts. So these fast radio bursts emit in all different wavelengths of radio frequencies. And so by observing the fast radio burst in a full radio spectrum, we were able to see how long it took for the different signals to reach the Earth and measure the time difference that it took for different signals to reach the Earth. And so that was what our research was on. And so this sort of feature was also a possible indicator of repeating behavior by analyzing the different wavelengths that the fast radio bursts repeat in. So, from our research, our goals was to study this FRB to see the time differences in the wavelength. And then we also used the telescopes to identify new repeating fast radio burst candidates. And these results are all contributing to the Pulsar Search Collaboratory database. And so the methods that we used to analyze this were just analyze existing data using the using Jupyter code and Python code in order to analyze the wavelengths. We were able to conduct observations through Skynet, and the telescope which we used was the Green Bank 20 meter. So, this was also what I wanted to go over. I think I went over it in an earlier slide, but this was about the new pulsar discovery. And so this is the plot of the new pulsar that I discovered. And so the features, like I mentioned before, it has two strong signals, and it has the swept bell-shaped dispersion measure, and then clear phases. And so with that, that's all of the research that I did with the Pulsar Search Collaboratory. Here's the link for more information about the Pulsar Science Collaboratory program. This is the link. And here's my video on my visit to the Green Bank Telescope. It's on YouTube. And my YouTube channel is Arjun Meenashi Sundar. So if you do check out this video, make sure to smash the like button and give me a subscribe. And so the last update is I have a article upcoming in about the PSC program, and it is to be published in the Astronomical League's Reflector magazine in the March 2026 issue. So that's something to look out for. And so finally, something interesting that I found. I went there and I was able to find Einstein soap. So the bar has E equals MC squared engraved on it, and the cover photo is kind of funny. Um, I don't know what Einstein really smelled like, but I guess I did feel smarter when I used this soap. So yeah. And finally, I'd like to thank everyone for listening to my presentation. And once again, here's a picture of me at the Green Bank campus. It's really a great campus. If you go there on a dark, moonless night, you can see the Milky Way really well. I wasn't able to take my telescope out there to observe because of the radio interference and stuff, but I was able to see it with my eyes, and I think it looked really cool. And so with that, yeah, that's the end of my presentation. Thank you so much for listening.
Arjun,
Yes.
I have two quick questions for you. One
do you
is,
know? Oh, go ahead.
go ahead. All right, Joe.
Okay, Arjun, do you know about the X-ray gamma ray bursts that are pulsars?
Yeah, I know about those. Those are like the super high energy ones. So I
Yeah.
think we didn't start observing those yet. Like the Green Bank does observe them, but then we were just looking at the normal pulsars.
Yeah, there's a telescope that NASA made. It's called NICER, and
Yeah,
it observes those pulsars.
yeah.
And
Um,
the data is free.
yeah, I think with the pulsar data, there wasn't much in the processing part for me to do, but I think definitely I'd go and check out the data.
Yeah.
Thank you so much.
So Arjun, the two questions, one is, I'll tell you both the questions right in front. So one was,
Yeah.
what was the most exciting thing for you? What really got you going, while you were out there? And the other one is, with the capture of the pulsar, with the two peaks, with the rate that the pulsar moves, especially millisecond pulsars, why is it limited to two peaks? Why aren't you showing more peaks?
Oh, okay. So, I think I'll answer your second question, first. So it's limited to, it's not limited to two peaks, but, the standard that was used is just observing these two peaks because after that, it'll just keep repeating the same thing. But two peaks are just enough to tell whether it is a pulsar or not because the signal needs to be like the same energy each time, and then it needs to have like the exact same amount of time in between. But I don't think I have a full plot of this after two. Yeah. And then for your second question, what kept me going out there? I think so I stayed at Green Bank for a week and so there was like a there's like a dorm there and I was able to stay there for a week and I got to roommate with someone and the whole experience was great. I got to wake up and I got to go and do research every day working with the scientists. So that super excited me. And also just getting to see all these telescopes in person was super cool. And now all of the time there was work. I got the trails there are super cool and the weather there was just super nice. So I got to go out and have some relaxed time. And so just being there made me want to, keep going and do this research because it all super interested me.
Arjun, the
Yeah.
pulses, the pulses that you showed, how do you know that it has that you should be seeing two pulses when a lot of these pulsars don't align up uh, at a 90-degree angle with their spin? So, I mean, you could be seeing the pulsar radiating from 10 degrees off of its pole.
Yeah, so I think that is one thing. So it could be rotating 10 degrees off, but as long as the signal is the same energy each time, you can tell that it's a pulsar because if the angle of the pulsar changes, then the signal could decrease or increase, which could throw the observation off. But by observing two, I think that just confirms that they're in close vicinity of timing and they also have the same energy. So I think that's how we were able to tell. But even if the pulsar was at an angle, the signal every time would be the same energy.
No, but yeah, but you would only see one pulse. You know, if it's a double pulse, how do you determine if you're only seeing one pulse or the second uh, pole of it?
Oh, okay, that's a good question. Um, I think determining on the timing of how far the peaks are, after you find the two peaks, it's whether it's the same pole that's seen each time or a different pole that's seen each time. I think the timing difference can tell because after doing this first observation, then they do more observations of it to see how fast it's rotating and just to find out the size of it. And so that'll tell an astronomer whether they're seeing only one pole or both. But you're bound to see the pole at least twice because it's spinning around, even if it's the same one.
Right.
Yeah, so that's how we're able to tell between the one pulses and then the ones which have both pulses.
Right. Thank you.
Yeah. Oh, and so one thing I forgot to mention is before I went to the Pulsar camp, I had to finish 1,000 of these Pulsar plots. So observing 1,000 plots like these. And the funny thing is, they considered each of these a single plot. And so I thought you had to get a new target every single time and observe a new target. So I actually did 4,000 instead of 1,000.
Overachiever, you.
Yeah, but a lot of the people made the same mistake because we didn't know that each of these were a single plot.
Oh.
But yeah. So
Arjun, before you finish up, could you tell the group a little bit about the new research that you're doing down at University of Maryland?
oh yeah. So this is not pulsar research, but some of the new research that I'm doing at UMD is I'm working with Miss Elizabeth Warner, who's the observatory director at UMD. Um, Me and her, she's my mentor, so it's currently like an unpaid internship where I go there and I observe asteroids for their color index, their occultations, their rotational period, and a rough shape model. And I'm using the UMD Observatory to collect data under Dr. Warner's guidance. So my first observation planned for is tomorrow, and we're observing asteroid 511 Davida. And then after that, we're going to be doing this for asteroids which have no information on them. So sort of like new discovery follow-ups for asteroids that aren't super dead.
Thank you.
Very
Of course.
nice. Thank you, Arjun. That was a great presentation. Really appreciate it.
Of course. Thank you for allowing me to give this presentation.
Oh, anytime. Alrighty. So, guess. Let's see if we can get this back up. Share.
Yeah, click the share button.
All right, so we're seeing it. You guys at home, are you seeing the PowerPoint presentation?
Not yet.
No.
Go back to where you were. After you, it's kind of annoying that Zoom does that. After you click share, and you gotta go down to the bottom of the screen.
Promise is. Yeah, so let's get back to Zoom meeting.
And I click that share button. at the
Yeah.
bottom.
There you go.
You got it.
So we good now?
Yes.
All right. So now this next little segment here is about Artemis, which, as we know, is going to be launching hopefully sometime this spring. And HAL's own Ernie Wright is one of the Artemis 2 visualization leads and has simulated views of the flyby using detailed topographic maps of the lunar terrain and photorealistic lighting scenarios. The crew is going to be using these visualizations that he's worked on to prepare for their mission, and it's going to pave the way for future exploration of the moon's surface. There's a great YouTube video, so I think we're going to try to share it. We'll see. And then Ernie is in the house, so hopefully he can answer any questions we have about that.
So the most exciting thing to me about Artemis 2 is just the return to the moon. We haven't been there in 50 years. Human eyes are going to see parts of the moon that haven't been seen.
Yeah, so just drag it to the right so it goes onto that screen. Yeah. And then if you full screen it from here, it should work out.
It looks just like yours.
Yeah, I know. There was shoots. But point full screen it.
So is that.
He's even wearing the same shirt.
There you go. Just click on the screen. Just go down to the screen. There you go. Just click on his nose.
By anyone before. It also recommits us to exploring the solar system in a way that we haven't in a long time. And I think it provides an opportunity for younger generations to understand the excitement of doing that kind of exploration. The moon is this great sort of chiaroscuro subject because the most recognizable thing about it is the changing sun angles and how that brings out the shape of craters near the terminator, which is the day-night line. Because there aren't, oceans and clouds and all the things that you see on Earth, the moon is really all about its shape. And the shape is telling you something about its long history and the history of the entire solar system. All the things that have happened to the Earth have been erased by geologic processes and weather and climate, and that doesn't happen on the moon. The moon has recorded everything that's happened since its formation almost 4.5 billion years ago. That tells us a lot about where we came from, where the solar system came from. It also reveals something about the composition of the Earth that we can't see because it's buried beneath the crust. Some of that is on the surface of the moon because it's been excavated by all the impacts. Artemis is our return to the moon after 50 years. The emphasis of Artemis is going to be, first of all, science, but second of all, learning to sustain a presence on another world. First on the moon, but we're hoping that that's a stepping stone to Mars and other destinations in the solar system eventually. Artemis 2 will be a flyby mission. It's not going to land. We're testing all of the technology that we've created for flying to the moon since Apollo. A lot of systems have been modernized, and we need to make sure that all of those work. The astronauts will be looking out the window at parts of the moon that have never been seen by human eyes before. They will be flying by the moon at an altitude that's much higher than Apollo's orbits. And so they will see the entire disk of the moon, including areas that are closer to both the North and South Pole that astronauts from Apollo never saw. All of that depends on the lighting, which we really won't know until launch day, but we can practice with different lighting scenarios. It's hard for people to sort of picture that in their mind. If you can make a visualization of it, show them a movie, that helps everybody choose the targets and also practice aiming at those targets. The astronauts have actually been looking at these visualizations through the lens of the camera and practicing aiming at the various targets. This is a map of the surface of the moon, obviously, but it shows what the Apollo astronauts could see in sunlight while they were in orbit. The brighter parts are the parts that they could see. The darker parts, like this entire area here and places that are farther north and south, are places that they couldn't see in sunlight, either because it was nighttime there or because it was beyond the horizon of the astronauts. All of the Apollo flights orbited the moon at a distance of about 110 kilometers. Because the astronauts were flying at such a low altitude, their horizon was actually quite close and they couldn't see the North and South poles. And this whole area over here was not in sunlight at the time. And it includes this amazing impact feature here called Oriental. Oriental is a very large impact feature. It's about 650 kilometers wide. It's got multiple rings. These are rings that form like ripples in a pond from the impact, but of course it's on a huge scale. The middle of Oriental has that sort of dark basalt lava covering it, like the dark spots that we see on the near side. It's one of the biggest ones that's more on the far side than the near. So seeing it with human eyes and sort of picking out features that maybe you don't even see in robotic cameras is an important goal for the mission. One of the photographic targets that is on everybody's list is pictures of the Earth beyond the limb of the moon. During Apollo 8, on their fourth orbit, they finally turned their spacecraft around so that they could see in the direction of the Earth.
Oh, God, look at that picture over there. There's the Earth coming up. Wow, that's pretty. Hey, don't take that. It's not scheduled.
Get a color film, Jim? I think it surprised all of them how beautiful and how human it was to see the entire planet Earth from behind the horizon of their celestial body. That photograph called Earthrise had a huge impact on the public because from space, you don't see country boundaries, you don't see some of the human problems that we deal with on the surface. And you also recognize that the Earth is a finite place. It's not infinite, it's not everything. It is a pale blue dot in the vastness of space. Artemis is going to have that opportunity once again. I anticipate that the astronauts will have the same feeling that the Apollo 8 astronauts did. And I think it will have a similar effect on a new generation of people who are watching this mission unfold.
Excellent.
A lot of credit to the producer of that video, Dan Gallagher. That wasn't scripted, but what they typically do is they put you in the studio for about an hour and start asking your questions. And Dan was able to take 6 minutes of that and put it together into a story that actually made sense.
That's really well done.
You probably didn't see it, but in the middle of the video, there are a couple of still photographs of the astronauts sitting at tables with their Nikon cameras pointing at screens. I was kind of in the back corner of the room when they were doing that. So I have met the astronauts. It makes the mission very personal for me. I'm very worried about them now. Because, you know, it just would have been some people that were going up in space with them. And Victor, you asked me if I was excited. Of course. Like some people in the room, I'm old enough to remember Apollo 11. I was 6 years old. My dad woke me up to see them climb out of the LEM. He was a huge fan of Apollo, and if he were alive now, he was very excited for his options. So I have something to do now. I'm going to be in mission control in Houston during the mission. We are going to be putting together an observation plan for the astronauts after the launch. We don't know what the lighting conditions are going to be because we don't know the time they're going to get there until they launch. So they launch, they do a low Earth orbit, and then they do a very high elliptical orbit that takes about a day around Earth. That's to check out all the systems. In that orbit, they come back to the Earth and they can choose to splash down if they want, if something goes wrong. But if nothing goes wrong, they will do what they call TLI, the translunar injection, and go up to the moon. And at that point, I will get the trajectory that they're actually flying. And we'll have to very quickly make a 6-hour movie of what the moon is going to look like when they get there. I hand that over to a group of scientists who pick the targets based on what's visible. So if something's completely in the dark, there's no point in looking for it. They choose a different target. We've been practicing this for about a year. I've been to Houston 4 times already. I thought I would be there for this meeting, but the February launches were scrubbed because of a leak in a fuel line that fills the SLS with hydrogen. And this is a problem they also had with Artemis 1. And the real problem is that hydrogen atoms are really tiny. They can sneak out of the hose in 100 different ways. So they're working on that. They're going to test it again. The next published launch opportunity is March 6th. So there are 5 days we can go, 6, 7, 8, 9, and 11. We're not actually skipping a day. All of these are night launches. And so by the time you get to the 11th, we pass over midnight, and each launch window is about 25 hours after the previous one.
Awesome. Any other questions here?
Yeah, Ernie, was that you speaking?
Yes.
Yeah, Ernie, my name is Joe Novotka. I worked on one of the payloads that's on Artemis, and I was wondering if it went through for NASA or did it get scrapped? It was the what did they call it? Oh, the laser communication system.
Oh yeah. Now I'm not actually an expert on the payloads, but I think that one that's in there, I think that's one of the things that they'd like to test because
Right.
I know that soon after the flyby, we are going to get downloads of pictures that they take. They're taking Nikon D5s with them.
Yeah, it's at KA rates.
Yes, and so it depends on whether we can get laser communication or whether we're going to have to rely on radio, and whether we can use the directional antenna or the Omni. We'll either get 2 pictures or 100 pictures or 1,000 pictures.
Right.
Right. So
Thank you.
yeah, I think that is going.
Just out of curiosity. Yeah, I was curious what you mean by you won't know the lighting conditions until the day of the launch. Is that because you won't know which day the launch is?
Yeah, exactly. We
Okay.
won't know what time they get there. That's all it is.
Gotcha. Because
we
I was
can-
thinking, it's like, well, there's not a lot of clouds. There's not a lot
That's
of
right.
like other things to get between the moon and the sun, so it should be fairly consistent.
No, we just don't know when.
Right.
Okay. But you saw a lot of the visualizations that I've already done, based on, whatever sun angle is.
Okay, that makes sense.
Yeah.
Why the D5? Because that's an older technology camera, right?
That's why. That's why.
Because it takes a very long time for NASA to approve anything for spaceflight.
Yeah.
The astronauts will be taking along tablets. We call them personal computing devices, or PCDs. They're actually Surface tablets from 2015.
Yeah. So Ernie, if I could just contribute to what you just said there,
Yeah.
just for a historical thing. So I was at Sony for 23 years.
Okay.
And I have to tell you, when the spaceship went by Pluto, that main chip on that was a Sony PlayStation 1 chip in there. And they knew that the technology had way surpassed it even by launch time, but there's no service calls.
Right.
And it was the most dependable chip in the world.
Wow.
And they put it on there and look what it did.
And New Horizons went as fast as it could.
Right.
Right. So,
So yeah, so you gotta work
with what you got.
Yeah.
Are they aiming for a particular approximate moon phase? Or are they just, whenever they can get off the ground, they're gonna go?
Thanks for mentioning it, by the way. That's cool. A couple of years ago, it was not clear that they cared at all what the astronauts could see. But the lunar science team was put together to plan their observations, and we pushed very hard to try to get a launch date where they could actually see something on the far side. So it is now a mission consideration.
So that puts it kind of close to new moon?
Yes.
Okay, the reason I was asking, so not only are they gonna be the farthest from Earth, could they be the closest to the sun?
All right, so I'm going to mention that to the science team. That's a really good question. A question that hasn't been asked yet, but I anticipate, is why there's such a wide swath of the moon that was never in sunlight when all astronauts were there. It's because they always went so they could land in the early morning. It's not super hot. The shadows are long enough. They can see topography as they're landing. So that morning lighting meant that they landed anywhere between, waxing crescent and first quarter. And so they're in orbit during that time, and the sun never gets around to Oriental, never gets around to that western hemisphere. So that's why they never saw it in daylight. They did see it in Earthshine, but that's kind of the same thing.
Are there any subtleties to time keeping on the moon? Not still, maybe not so much for this. Maybe they just stick to Eastern as EST or something. But like, this is a precursor to like landing on the moon. So do you you talk about the sunrise on the moon. Like, is there any weird timekeeping?
There is a whole working group about lunar time standards. And you're right, it's not going to affect Artemis 2 that much, but if you want to have something like GPS on the moon, you have to establish a time standard for the moon, and it's not the same as the Earth. You're not in the same gravity well, you're not orbiting at the same way. At very precise levels where you can do GPS types of things, we need to figure that out. But mostly, we just kind of take the 1.5 second delay in stride and let them, there's a clock on the ship, and one of the things we've suggested to them is that periodically they take a picture of the clock on the ship. Because we don't know if we're gonna get the camera data, whether the time on the camera is gonna be accurate. And so we wanna make sure we can compare the metadata from the camera to the picture of the clock on the, like, this is really low tech, but the picture of the clock in the capsule to sort of synchronize when those pictures were taken.
Oh, exactly. Yeah, but you talk about like effects of time from like relativity.
Yeah, I mean,
Okay.
at GPS level, you really have to be at this.
Right, it has to be super precise.
Yeah. So that's why they're working on it, but it's not gonna affect ours. It will affect future ours. Because we want, if there are proposals for GPS-like systems for them, and that would help land.
Yeah, will the spacecraft be coming up the East Coast? And if so, would we be able to see it from here?
I'm not sure you'd be able to see it from here. You're a lot more likely to see launches from Wallops, as no. I don't think it's going to be that inclined. It's not like the shuttle. It's going to stay pretty near the equator, pretty near the ecliptic. So I don't think it's going to come that far north to see it. But I don't know what the orbit looks like. So there's a chance that we might be able to see it. I just don't know anything about that.
They're on the far side, but they're further away than Apollo was. Will there still be communications blackout when they're on the other side, or are they going to be able to bounce?
Yeah, they'll have loss of signal for about 45 minutes. Something Apollo didn't have is the Themis satellite constellation. So Themis is a geosynchronous satellite group. I think there are 5 of them that helps with Earth orbiting satellites. So you can, even if you can't communicate with the far side of the Earth, you can bounce it off of a Themis satellite. So loss of signal will be slightly shorter than it would be otherwise, but it's still only 10 degrees wide, the whole Themis constellation. So there will be about 45 minutes of loss of signal where they will be by themselves.
Hello, Ernie.
Any questions online?
Yeah, I do. Ernie, I was wondering how many orbits are they going to do around the moon?
None. 0. Well,
oh, so okay, so they're just going out. They're going to do that little figure 8 shape, and they're going back.
Yep. Yeah, I mean, the mission's been compared to Apollo 8, which was the first time we went to the moon, but we are not going into orbit. Apollo 8 orbited 10 times. And that was a last minute decision also, and a risky one for them to actually go into orbit, because the service module, the main engine of the service module had to fire twice, and they've never done it before. Artemis 2 is doing a free return flyby. They will be about 7,000 kilometers above the surface of the moon closest approach, versus 110 for orbits for Apollo.
And it's more like Apollo 13.
Yes.
Without a problem.
They didn't have duct tape, that's all that matters.
Without the exploding bits, you sure hope.
Are the air filters at least the same shape?
I can't guarantee that.
There's no lunar models.
No, but I mean, Orion and the service module part of Orion is an international affair, and so I don't know if we're going to have inches versus centimeters.
Oh my God. Do you know if there's going to be some kind of streaming of the launch? For
Yes.
people to follow up?
Yes. NASA's new streaming platform is called NASA Plus, because everything is plus with streaming, and they will be streaming continuously. If you have the stomach to watch it for hours on end, you may even see me in the back room. There will be a camera in the back room at Mission Control aimed at the scientists who are curiously coming up with an observation plan that they can upload before the astronauts arrive. But there will be, I'm sure they'll show my movie 100 times. There's a bunch of other stuff. But so it's going to be live streamed. You can watch it 24 hours a day.
Okay. Daniel, to our last question here.
Is your name Bernie Wright?
Yes.
And you're gonna be, you the one that made that YouTube video?
Yep.
Very nice. So
Yep.
they're gonna take one, when they launch, they're gonna go low orbit, one orbit around the Earth, that'll take a day, then one orbit around the moon. Is that how it will be?
There'll be an orbit, a low Earth orbit that will take about 2 hours. And then there will be another orbit around the Earth that will take about 24.
Elliptical?
Yes, elliptical, and it's gonna be 10,000 kilometers, 12,000 kilometers. It's gonna be farther than we've been in a very long time.
And then one orbit around the moon and back.
Yeah, they're just gonna go to the moon and come back. They won't even go into orbit, but yeah.
Just gonna go and come back and make an orbit around the moon?
Yeah, they'll orbit.
Well, thank you.
Yeah. And then it'll take about 10 days. And the launch is at night, the splashdown is at night. So
We wonder what aircraft is carriers gonna get about, do we have any idea what the aircraft carrier?
I don't know which one. I don't know.
Ernie, thank you very much.
Wow.
Alrighty. So for shallow skies, I was going to basically, I'm going to kind of run through this really quick because we got some great astro photos. This is the time of the year that is really great if you don't know the constellations to go out and to learn them, because you've got some really bright, easily recognizable constellations out there. So if you step outside like around 8 o'clock at night and you look south, you're going to see Orion, which of course, you know, the classic 3 stars in a row and kind of like a tilted rectangle there. If you go down the line of stars, you come to Sirius, the brightest star in the sky. That's the constellation, the big dog. Go the other way, and you'll have an orangish star, which is Aldebaran in Taurus. Continue on, and you see a little fuzzy thing. If you have halfway decent light pollution conditions, called the Pleiades or the Seven Sisters. You can go from Rigel through Betelgeuse, the 2 brighter stars in Orion, up to a very bright thing that is Jupiter. And you can continue on to Castor and Pollux. And of course, you can also go to the side to Procyon. So it's really a great time of year to go out. If you're not familiar with the night sky, take the opportunity to go out and learn your basic constellations here. And then we do have a total lunar eclipse for March the 3rd. So for us, the totality is going to occur with it very low on the horizon, and it actually sets during totality. So you're going to need a really good western horizon to see this. And unfortunately, this is the last shot until 2029. So the ones in 2029 are well placed for us. This one, not so much, but you can at least see the partial phases. And if you have a good western horizon, where is it you guys go out for the comets?
Howard County Conservancy, yeah. Yeah, Howard County Conservancy.
Okay, maybe, who knows, somebody, Jose, maybe he'll organize an outing to there to watch the eclipse. We'll see. Keep your eyes peeled and check your emails. So now let's get into the member astrophotography that we had this month. Our very own Victor Sanchez, the Large Magellanic Cloud.
Yeah, so I went to Chile this month, and I was able to bring my mobile astro rig, and I'm actually putting together a little report that whenever Jim is ready for me next month or the month after, I'll talk more about the trip and where I was and all that. But this is the Large Magellanic Cloud with just 2 hours of light. This was like 50 minutes of just a UV IR cut filter with the camera's a color camera. And then I have a hydrogen alpha and oxygen 3 filter. It was about 70 minutes of that. The amazing thing is I was at elevation, I was at about 6,000 feet elevation and I was under border like 1 or 0 skies. It was in the mountains to the east of Santiago, Chile. And I didn't really notice it until afterwards when I was post-processing, but the UV-IR cut filter almost shows as much detail on all of the nebulosity there as the HAO3 filter. I mean, there was no light pollution per se. So the HAO3 filter just diminished the brightness of all the stars. But other than that, you could pretty much see all of that nebulosity in all of the subframes. It was incredible. Anyways, that's
Beautiful shot. Very nice. Now, what's our appetite for your presentation?
yeah, it's great. I'm excited to do it.
Okay, Wes, are you online?
That's me right here.
Oh. See?
It's all good.
All right.
Yeah, so this is Bode's Galaxy. It's my first attempt at at like a legit deep sky. I got a bunch of good suggestions from the Discord group on how to process it. This is also where my telescope decided to stop moving partway through the night. So instead of the 6 hours I was hoping for, I got about 2 hours, and then I watched that nice center go doop, 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 out of the frame. But you know, processed what I got, and I was pretty happy with it.
It's very nice. You can see the dust lanes and the spiral arms.
Yeah.
It's great.
And this is the Crab Nebula that I took on that very cold impromptu. It's just less than 6 hours. I collected 6 hours of data, but I threw a couple of exposures out. It's RGB, no H alpha or anything, just RGB, LRGB, excuse me. So, some alpha rich part.
Love the tendrils in that. It's great. Beautiful shot.
Pulsar in the middle.
And the pulsar is visible, yeah. Don't know which of those 2 stars it is. Pulsar is visible. Which one went up there? What's that?
Okay, Rich, are you online or here in the room? Okay, I received this one from Rich, and he felt almost, I think, a little embarrassed that it wasn't good enough, but I mean, my gosh, you look at it, it's just fantastic. He said, you know, that in the emails to me that he's really climbing that PixInsight learning curve. But I would say that he's doing pretty darn good with that, because that's a great shot of M33. Now, you love the, you know, the H2 region there. Just gorgeous. Yeah, what is it, like 40 something or other, 604 or something.
Can't remember his name, so
I think he's got one more. No, here's Daniels.
I took this picture back January 15th of 2020, this past January 15th of 2025, and in the brightest one there is Venus, and the one on the left in a 10 o'clock position is Saturn. That's the star right there. See, they two next to each other. Yep. Let me point it out. So
very nice.
Boy, that's Venus, and then that in a 10 o'clock position, that's Saturn.
Very good. Nice conjunction shot.
That picture turned out wonderful.
Yep.
It's pretty with the trees there.
Yeah.
Yes.
That's interest to it. Ian, are you on?
Yeah, I'm here.
Okay.
Yeah, this is a tiny section of the Rosette Nebula with my 11-inch stochastic grain at F10, and just started using Nina and Searle. So I was happy, kind of happy with that as a start.
Yeah, no, definitely.
Congratulations.
I think we have one more from there. Yeah.
Oh, that's Caldwell 7, and yeah, there's all 82.5 minutes total exposure. Again, the 11-inch. I wanted to try some guiding, but the guiding turned out to be worse than the native mount tracking. So I'm just starting with guiding and all that.
Yeah, it's a learning curve for sure.
Yeah.
Especially with the SCT.
Yeah. Yeah, I don't think I need a far.
So I had a night where clear skies, and I was able to do a full rotation of Jupiter. I stayed up, started at like 8 and then went to bed around 3 in the morning. So you can see we start off with the great red spot getting ready to set. And then here I'm catching it as the scene was going south as it's beginning to rise.
Wow.
And
He should
with,
turn that into a poster and sell it.
with that, you can then use WinJupos to make a map. So that's a map of Jupiter, how it appeared on that night. And you can see not only the great red spot, but there are a bunch of these long enduring storms here. There's an oval BA. This is a new feature which has erupted this apparition. It's a ring and it's high up in the atmosphere. So that was a great night. Don't get many of those. And especially in the winter, you can go the whole, 8 hours or so to get a full rotation.
Was that Europa that was?
I think it was, yeah.
It's almost right on top of it.
Yep, I think it was Europa that night.
So Jim, what do you? Go ahead.
No, go ahead.
What do you use? What's your setup to do that?
It was a 10-inch f6 scope. I'm not going to go back for that. It's a reflector, 10-inch f6. Actually, the mirror was ground by somebody from the Baltimore Astronomical Society many years ago. It's nice optics, ATM optics.
So Jim, what's your thoughts on the latest news on Jupiter that science has determined it's not quite as large as it's been talked about forever? It's been caressed, even though we'll never tell it that, but.
I don't know. To me, how do you measure a gas thing like that? It's difficult, but I don't know. It's plenty big. I love imaging it because you get such nice details all of it. Okay, I believe this is Steve. Are you online? Usually you're online, Steve.
Yes, I am. Yeah, I can only do so much from my backyard on Mount Airy, and one of the things I'd like to do is try to see if I can image the faint moons in the solar system. I've managed now finally to get 32 moons, with my last one being an Anki Jupiter 12. It took several tries, and in order to be sure you've gotten these things, you need enough time to see that they've moved. And many times I'll get the first exposures, and a few hours later, clouds have come over. So, but here I did have enough time to show, I think you can see that there's a little dot at the end of the arrow on each side that it has definitely moved in the time, in the hour or so between the two images.
See the bright star, just go up to the right of the bright star.
I see this one here.
Yeah.
That's it.
This
Right
one
next to that bright one, yeah.
Right here.
And
Yeah.
you see it's
Right there. Oh,
moved
my.
right, and you see it's moved over to there. Yeah.
Okay.
Yeah.
Wow.
So it moves enough in an hour that I was able to show that was definitely it. Yeah, and that's almost 19th magnitude.
Wow.
Wow. Well done, Steve.
Wow.
Yeah.
This is a
And
bad time to look for them because there's so many background stars where Jupiter is now.
Yeah. There are a few others that I won't be able to get because they're too close to the planets, and without an occulting disk, it's not possible.
So Ernie, keeping with the theme of Jovian moons that are not the standard Galilean ones, he submitted this little GIF of Amalthea and Thebe. Ernie, are you?
Ken.
Ken,
Yeah.
I'm sorry.
That's okay.
Ken, are you on?
Same thing. I can see Amalthea and Phoebe to the right of it, but there's so many stars. How do you prove that that's actually them? And so here's about 5 or 6 shots taken 10 minutes apart or so. You can see the two to the right are moving along from Jupiter, and it's brighter than Io, whereas the stars are motionless.
Very nice. And what size instrument are you using?
It's
here?
14 inch.
14 inch. ASI 2600 and 2-second exposures. Beautiful. Lots of amazing talent in this group, I tell you. And Ernie?
Yes, so this is Tadpole Nebula and Flaming Star Nebula in Auriga that I took at Alpha Ridge Park in 2 nights, one in December and one in January with my Vaonis Vespera Smart Scope. Just did a little processing with Crackspert and Serial and Affinity Photo.
Very nice. It was funny, I popped that into Chat GPT and it told me it was the Heart and Soul Nebula. And speaking of which, here is the real Heart and Soul Nebula.
Yeah,
And
I just got
gorgeous.
a little bit of the Soul Nebula down there at the lower raft. So this is Happy Valentine's Day, everybody. This is Heart Nebula in Cassiopeia and the Fishhead Nebula there in the upper right. And to the left is an open cluster NGC 1027. And this was done actually not really recently. It just took me a long time to get around to processing it. But this was 6 nights at Alpha Ridge from August to October. And I did 12-second sub-exposures on this instead of the standard 10 and increased the sensor gain by 20% as well using a dual band filter, H-alpha and O3. And so it's total of almost 13 hours of the sub-exposures with a mosaic that's 3.8 by 2.2 degrees.
Beautiful job. Really nice.
Thank you.
And with that, let's see if we can find our auction winners. All right. So we have, looks like Ken scored. Did Ken win all of this?
Ken's here.
No one was bidding on the telescope. I felt sorry for it. Well, that's a sweet setup. So very good. All right. Congratulations all. And
You got
Who got the focuser?
Yeah. Somebody put in a bid at 843. That was me. Oh.
Totally told it was risky, and then I got bid out again anyway. So
Yeah, I saw that.
yeah, somebody then got it at like 8:44 and 30 seconds.
all right. So without its glitches, we got through it. By the way, we have a planning meeting. If you guys ever want to come to a planning meeting, feel free to drop by. They're Zoom based. You know, and you can give us ideas about what you'd like to see, give us feedback, or just watch us try to figure out what we're doing for the following month. And safe driving home, guys. Thank you.
Back the way they were, or
I don't need to worry about it.
no?
There you go. You made it through your.
Nice job.
Just barely.
Hey, you know, I was talking with Victor. If you can't get in, or you don't feel like, if you check with one of us, you could run it by home, and one of us could come here and sit.
That was part of the conditions for me taking this.
Well, I wasn't sure.
Thank you for reaffirming that idea, because I
just thought
definitely
about
do
it.
that.
And I know that drive very so.
I'm definitely going to be doing that.
No, you just gotta.
No,
Phil.
like 50%.
Hi, Phil.
Yeah, but even so. I appreciate it. Maybe do it together, or just one of us can
Hey,
make.
hey, Jim. Jim.
Yes, yes.
It looks like we just raised $5,000 with that auction.
Hey.
It's a lot of money.
Well done, guys. Talk to you soon.
All right.
Yeah. So, do I have to? Yeah. Somebody I put my. I actually don't like going there. Was it snowball stand thing on the corner?
I've been wanting to get.
Yeah, so I'm gonna find a good spot for low around the big stuff. But you can still go, send me an email, I'll give you the.
Yeah, that is the last chance in a couple of years. Like, I tried. So I'm gonna try this time. I would go out. I haven't practiced. I don't know how. This is where we're gonna have. Oh, I may open tomorrow. Yeah, I got.
Pittsburgh and then the Antelope. I'm gonna look at colleges with my kid.
My bed faces skylight.
So,
I'll see you guys.
I'm hoping to.
At night, like, fall asleep, like, can I get a?
I also strongly recommend starting with small colleges over big ones, because big ones are, at least in my experience, more about just like memorization and just trying to turn out, numbers with degrees rather than actual
And I
work.
still see you.
So,
Right. And to become like that, that I can't see it, still there.
I
got. Good night. Nice seeing you. Nice seeing you, Jim.
Good seeing you.
Well,
Thank you.
when the weather gets nice, yeah, let me know. There's a little
Probably.
Oh, yeah. If the weather is nice, I'm gonna call an impromptu tomorrow night. So I still have to double check my kickers. My kids.
I'm not sure.
Okay, we're set for next time.
We're getting there.
You've got Navy.
Aerospace. I don't know if you'd like to see the pictures, but from the
But then actually.
I wasn't up late enough to see like the dark skies, but the sunrise.
Well, it was. Right.
Yeah, I took a lot of photos from the space.
There's a color camera.
Walked up, he's right away.
Last time equipment was
747.
So I'll have to.
Right.
Now that I'll be real, right? Yeah.
Yeah,
so I work in the office directly. Yeah, so I live in Millersville, and then
and RS
actually but it's still definitely a hike to get out there.
got a model of the space.
Like I don't mind waiting at the third party to grab it.
There's
See, I'll send her. Yeah.
They have a model, the full size model.
Motivates me.
To a start stage.
Because it felt like last year, every single, every start party, there was, it was like so many start parties and also and your personal right, there's something on it. Yeah, and it just felt like every time it was either like, I actually had like something else happening. It's just totally or something, right?
They also.
It was just like,
Wow.
there's always something. You know what, so I'm trying to like start new projects. I shared the program, okay, yeah. Start my calendar and I. So now you have other people being like, hey, how's that calendar going? Yeah. So somebody's push me.
I was there from, so I left on Thursday, February 29th. And then I spent a day in Houston, and then took the bus over to West Texas, where I went from, I think, for 5 days. And then I came back last Saturday. Yeah. There's more cool photos from here. The second day of the starting.
Yeah, we just get an operator on it. It's
Sure about it. And you think it's so much people then I bring back.
Right.
But it
Okay.
was, want to have more people. But you know that you're in. That would be fun.
Yeah.
You want to go.
Yeah, it's one of those things where it's like, I'd like to get more involved. It's like, especially with.
You can all
right now.
hear already injection valve.
I have no overhead time. Like,
Then it's just
really get in a position, but like, I think definitely running into
There are full scale.
Right.
You're a little bit of. I didn't really.
What part of the country in Chile would you want?
Just getting around. Someone talked about it at the time. But once you're. Just go off to the.
Right, yeah. So you just had Google conflict already, so we got it, bro, you're done. Oh, I'm kidding.
I first started, I had so much trouble.
This meeting is being recorded.
Yeah. Ernie's kind of. And yeah, it starts to get like $200. No, people start writing notes that you have stuff.
I cannot get Zoom back up to.
Yeah, I definitely want to come up with one of the star parties. Last year was just like everything, it seemed like every time, and then like, get to like the end of August, then we're. It's like, my family vacation.
Yeah, I wonder, I don't know, do you think I should submit a slideshow of the pictures from Houston Space Center for the next meeting?
Yeah.
If you all would be interested in that or not.
Come to the planning meeting, tell us.
Okay.
Yeah.
Yeah, maybe I can send like a PowerPoint to Victor that could be included in the next
That would be
thing.
great.
Maybe I can stop by or do an online thing.